everybody. I'm Miss Cooksey, and today we're going to be talking about the multiplication and division properties of exponents. So we're going to do a little bit more evaluating and simplifying with exponential expressions. So there's two different rules we're going to learn here. The first is the product of powers, and the second is the quotient of powers. We're going to start with the product of powers. The reason we call it the product of powers is because we are multiplying two terms that have the same base and both have exponents. So here, a to the m times a to the n. The important thing to realize is that these have the same base. This rule does not work if your exponents have two different bases. So if this was a to the m and b to the n, this rule would not work. You have to have the same base. So when I'm multiplying a to the m times a to the n, I'm going to add my exponents together. So a to the m times a to the n is equal to a to the m plus n. Next, we have y times y to the fifth. Well, every single term has a secret or invisible exponent of 1 because y to the 1 is equal to y. So this is actually the same as y to the 1 times y to the fifth. Well, y to the 1 times y to the 5 is equal to y to the 6 because 1 plus 5 is 6. Next, we have m squared times m to the 7th. Well, product of powers says that we add our exponents when we have the same base. So 2 plus 7 is 9. X to the 4th times x to the 3rd, 4 plus 3 is 7. N to the 5th times n to the 3rd, 5 plus 3 is 8. In this last example, it looks a little bit more complicated, but we are going to just remember our multiplication rules, remember our product of power rules, and we are going to add the exponents that have the same base. So let's start with our coefficients in the front. 4 times negative 3 is negative 12. A to the 3rd times a squared, 3 plus 2 is 5. B times b to the 5th, remember this b has a secret 1, so b to the 1 times b to the 5 is b to the 6. And then c, oh, no more c's over here, so we're just going to write c. Negative 12, a to the 5th, b to the 6th times c. The quotient of powers is going to work very similarly, but this time, quotient, we are dividing terms that have exponents and the same base. So a to the m divided by a to the p. I think this should be, oh, okay, I did a p. Great. A to the m divided by a to the p. Well, when I'm multiplying exponents with the same base, I add my exponents. When I'm dividing exponents with the same base, I subtract the exponents. So here, x to the 3rd over x to the 1, remember, always remember that invisible 1. That's a really easy thing to forget. X to the 3rd over x to the 1 is x squared because 3 minus 1 is 2. Y to the 5th over y squared, 5 minus 2 is 3. Negative 3m to the 7th over 15m to the 4th. Well, first we need to simplify these coefficients. Negative 3 over 15, negative 3 and 15 both divide by 3. So negative 3 divided by 3 is 1, and 15 divided by 3 is 5. So I'm not going to write out that 1 because it's unnecessary. Anything multiplied by 1 is itself, but then I'm going to write the 5 on the bottom. So I have negative 1 over 5 for my coefficients. All I did there was simplify my fraction. Negative 3/15 is equivalent to negative 1/5 because I divided the numerator and the denominator by 3. Then I have m to the 7th over m to the 4th. M to the 7th over m to the 4th, I'm going to subtract my exponents. So 7 divided by 4 is 3. Negative m to the 3rd over 5. In this example, it's going to get a little bit weirder, but we're going to talk through exactly how it works. Here I have r to the 1 over r to the 4. Well, that equals r to the negative 3 because 1 minus 4 is negative 3. We learned in our last lesson that negative exponents move. So if I have r to the negative 3 power, I'm going to write that in the denominator as r to the 3rd power. So instead of r to the negative 3 in the numerator, negative exponents are ugly. We want to make them positive. So I'm going to move it to the denominator and write r to the 3rd power. Then I have s to the 6th over s. Well, there's an invisible 1 here. 6 minus 1 is 5. That's a positive exponent, so I'm going to leave it in the numerator. So I have s to the 5th over r to the 3rd. Okay, last example. X to the 8th power times y to the 9th power times z to the 2nd power over z to the 3rd power, x to the 4th power, y to the 6th power. Let's start with our x's. 8 minus 4 is 4, so I should have x to the 4th power in the numerator. 9 minus 6 is 3, so I should have y to the 3rd power also in the numerator. And 2 minus 3 is negative 1. So instead of writing z to the negative 1 in the numerator, I'm going to move that to the denominator and have z to the 1 power, or z. So that results in x to the 4th, y to the 3rd over z. So in this video, we talked about the product of powers. When we multiply exponents with the same base, we add the exponents, and the quotient of powers. When we divide exponents with the same base, we subtract the exponents. Thank you for watching. I hope this video was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.